does go to tax sale or it changes hands, potentially we could collect that delinquent 5 years of taxes. So could be a long period of waiting. And again, a lot of times when property, specifically raw land, goes to tax sale, if there's no buyers, it will continue to go delinquent for years and years and years until the market comes back where it becomes economically viable for an investor to buy the raw land. I mean, it's really for an earthquake or anything else, we want to know what we need to have insured. And so that's an ongoing process. Hopefully in the next year or two, that inventory will be completed, that equipment will be tagged, and we can make this one go away. The second finding is dealing with the water banking, kind of a new procedure for the agency. What we have to do is that the water that we're purchasing and putting into the ground, we have to account for that. That's not a cost to the district as an expense, that's an asset, it's something that we own. And so now, for the last couple of years, we have the water inventory, which in the past we've never had. And how we calculate that needs to be the cost that we're actually acquiring that water for. And there was a miscalculation on how that water should have been costed out in the June 30th. That's now been corrected. It's being cost on a monthly basis as the water goes out there. And the very last one is we had a little glitch in the payroll system where there was a step increase where an employee should have gotten a raise and it was overlooked and not put on his paycheck. The dollar value of that insignificant is about $100 for the employee. He's since been reimbursed or compensated for that.
He's about 18 feet tall. Receive all over Southern California for groundwater treatment and to a lesser extent for surface water treatment plants. And they're used as a result of heat here for a variety of compounds. Basically, the sizes for East Side plant, working with staff, we talked about using 6 MGD capacity rather than a full plant capacity because you don't necessarily need to treat all of the water to get the impact or the effect that you want. So we size it for 12 vessels for the cost estimate. Again, 20,000-pound vessels, and the empty bed contact time, which is abbreviated here as EBCT, empty bed contact time, is defined as 15 minutes, which is typical for this type of treatment, precursor removal, TOC removal, or absorption by carbon. Because they're post-filtration, the water won't flow from the filters to the clear well. With this in place, you need to pump through the vessels and then to the clear well. It'll also delay the point of chlorination from the post-filtration area to after the water goes through these vessels. So not a major problem in design, just something to be aware of. This carbon in place is about $1.50, $1.40 to $1.50 per pound. So it gets expensive rather quickly. You come up with a cost estimate here that's $4.5 million. So that's the capital cost. To look at the operating cost, we want to look at what carbon usage and carbon replacement would be. So the top third of this graph, this slide, if you will, is you take the $4.5 million and you amortize it over 20 years at 5%, the annual payment stream would be $360,000. That just allows you to convert this to $60 per acre foot in the capital cost. So we know that the capital cost is $60 an acre foot. And we've assumed that we don't need to build the second phase of those 8 vessels because we think we wouldn't need to go that far because you already have other treatment processes to remove carbon besides just enhanced coagulation. You have the ozone biologically active filters, which helps you use less carbon for a plant like this. But we estimate that the carbon usage is still 300,000 pounds to 700,000 pounds per year. And that's about $500,000 to $1.1 million per year of carbon changeouts. You have other operating costs for a small amount for power, some for maintenance, and a small amount of labor, which totals about $100,000 a year. So when you add those together, you've got on the bottom 97 to 198, basically $100 to $200 per acre foot annual operating costs. You add that to the capital from above, and you have this number, which is the total unit cost for capital and O&M, which is about $158 to $260 an acre foot. And we've heard numbers of $270 to $280 per acre foot before, so that's not a new number. But that's the high end of the range that I'm presenting. So look at this graphically, much as you thought about before. That is, the top line here, which I'm calling GAC high usage, matches the numbers that were presented by MWH in the tech memo about 3 or 4 years ago. And that's the $270 an acre foot, basically. That's what typically costs for carbon, but that's when you have a plant treating state project water with only enhanced coagulation as your only other TOC removal mechanism. It's down-free chlorine, you need to lower the TOC. But you do get this additional benefit of ozone and biologically active filters that you paid for that's in place that's already helping you somewhat. So So that drops you down to what I'm calling this moderate use line. Now things are very favorable if you can bypass it, get good water quality, you could drop to the low line. But I would think of this, in my opinion, as you might operate the low line 1 out of 10 years, you might operate the high line 1 out of 10 years, but on average you're going to be on that middle line, which is still quite expensive because you'd be spending about $750,000 a year on GAC replacement and operating costs. So while this is a fairly low capital cost project at $4.5 million compared to the water bank, it's more expensive on an annual cost, and that's what I want to do is make a comparison. We divide the $100,000 by the fact that this is a treatment solution, a THM control solution for the 6,000 acre-feet average of the east side plant, and that's $17 an acre foot. If we then amortize the capital cost, the $8 million divided, still using 20 years over 5% interest, amortize that amount, it's $107. So the capital cost base is $107 compared to the other that was $60. The operating cost is now $17 compared to the $200. So when you put this together, the total unit cost is about $124 for this service area. So I went too far. Now there's also a benefit here of water banking. So if you put 3,000 acre feet over 7 years out of 10, in normal and wet years, not during dry years, you will put 21,000 acre feet on the ground, of which you can take out 15,900. So shown here in bold, assuming 3 dry years, that's the 11,900 acre feet that you could take out. And do this on average 3 years out of 10 into the future. And we had done this once for your other larger water bank. This is what would be the dry year benefit, the savings of having that water supply available. But if you do that again here, and that is in a dry year when you're short, when your allocation is way down, and your members are being cut back, they can go to the marketplace and they can purchase water, typically currently about $300 above their variable water charge, but also there's a transportation cost. You get it from some other water bank, if you will. It tends to be about $180. So this $480 number is a number we've used before here with the board. And if you apply that as a benefit to this 11,900 acre feet, 3 years out of 10, decade after decade after decade after decade, at the end of 40 years, the net present value is $8.6 million of savings. Savings to your customers who would otherwise have water available and have to go to the market to do a dry year purchase at these kinds of prices. So this net present value is millions of dollars.
Okay.
And so whether I had 8 million or 8.3 million, I decided it's safer to say that it's to be determined because we really don't know. But it's not.
You don't think it would make it a significant
Yeah, it
difference?
may push it a half a year. You're actually
Okay.
correct in that case.
Okay.
But it's not a multi-million-dollar task to purchase the kinds of property sizes that we're talking about. What the water quality is, what the historic strengths have been, some of which we can pull off the CDPH database. But it's not a couple of these all that potable. You can have anything on those others as well in production. So we could definitely gather all that, and then we can work with staff in your committee to determine, where to spend to get more information. Where we have information, we need more information.
I don't know what you control all that well in it.
You end up buying a site that's very, very close to 1 or 2 existing wells for 2,000 feet. You say, look, we already know. If you buy it a half mile away, you say, well, we're going to drill. It's all out there.
I might recommend, I know I've dealt with some well drillers, a couple of good ones here in the valley. They have a lot of knowledge in our valley. They're old-time people here that's drilled for years and years and years. And I know they saved us a lot of money one time. They have a lot of knowledge. I would hope that you could maybe use them as a resource to suggest, because they have a lot of knowledge about every area.
I would probably from them maybe enough information at least to start reviewing those costs. So I would like to ask that the Water Rates Committee would take on that objective and try to calculate what the water rate is costing AVAC and the recommendations for that class of service, what the rate should be. It's never popular, but unfortunately it's necessary.